Hey, we've seen the spectacular, violent cosmic funerals of massive stars, the ones that turn into black holes and neutron stars. But what about the gentle giants, the medium-sized stars like our sun? Their death isn't a bang, it's a beautiful, slow fade into oblivion. We're talking about the silent, cooling cinder known as a white dwarf. Forget speed and violence. The death of a sun-like star is an act of exhaustion. For billions of years, our sun has been fusing hydrogen into helium in its core. But in about 5 billion years, it will run out of that core hydrogen. When the furnace at the center runs dry, gravity starts to win. The core collapses, which actually causes the outer layers of the star to swell up, expanding to hundreds of times its original size. It becomes a red giant, swallowing up Mercury, Venus, and Earth. After this bloated phase, the star becomes unstable. It gently, slowly blows off its entire outer atmosphere into space. This gas glows brightly, creating one of the most beautiful and colorful objects in the cosmos, a planetary nebula. But the real story is in the center. All that's left behind is the incredibly dense, ultra-hot core. This cinder is what we call a white dwarf. It's physically about the size of Earth, but it still holds about 60% of the sun's original mass. This makes it hundreds of thousands of times denser than anything on Earth. So why doesn't this dense core just collapse into a black hole? This is where extreme physics saves the day. It's supported not by heat, but by something called electron degeneracy pressure. Essentially, the electrons are packed so tightly that they start furiously pushing back against gravity due to the laws of quantum mechanics. This outward push is what holds the star up and prevents further collapse. But there is a limit. If the star's core is more than about 1.4 times the mass of the sun, the Chandrasekhar limit, this pressure fails and that star collapses into a black hole or neutron star. Since the white dwarf has stopped fusion entirely, it has no energy source. It's just glowing intensely from the residual heat of its formation. Over trillions of years, it will simply cool down, fading from white to yellow, then red, until it becomes completely cold, dark, and invisible, a black dwarf. So the next time you enjoy the sunshine, remember its ultimate fate is to become a tiny, dense, fading ember, quietly cooling off into the eternal dark. Pretty wild, right?